Now it is time to present the grand prize winners. These are the components that, as voted by this year's judges, have achieved the highest level to which PM part design can aspire. As Walt Disney proclaimed, it's kind of fun to do the impossible. In the automotive chassis category for conventional PM components, a grand prize has been awarded to Phoenix Sintered Metals and customer Dana Incorporated for a stepped planetary gear used in a ridged rear axle gearbox for battery electric light commercial vehicles. To enable an 82-to-1 dual reduction planetary gear system, it was essential to be able to deliver tight dimensional control for this complex shaped part. The 5-level pinion is made using FL 4405-100HT. The parts have different fine gear tooth geometries at each of the ends. One end has a 15-tooth, while the other an 18-tooth, separated by a thin guiding flange that is also used for orientation during assembly. Both gears exceed the ANSI AGMA 2000-A88 Class 7 requirement. The pinion is oil impregnated. This provides lubricity while running and lower torque loss at startup and in cold weather conditions than grease. The concept of a dual reduction planetary gear system was possible because of CNC powder compaction. No other metal forming technology could provide the part geometry at a commercially competitive price. Dana performed bench testing for functionality, durability, and abuse at the subsystem level. The end customer performed vehicle-level endurance testing for performance, durability, and reliability, and comfort testing for noise, vibration, and harshness. The test duration for each phase was typically 4 to 6 months to complete the required array of tests. In the aerospace, military firearms category from MIM Components, a grand prize has been awarded to ARC Group worldwide for an enclosed striker used in the firing mechanism of a commercial handgun. The part is made in a 2-cavity mold. Strategic tool design and staging was implemented to mitigate differential shrinkage out of sintering, which often occurs with long, thin geometries. The additional upfront engineering was rewarded as the ideal staging method was identified, eliminating a sizing operation. Post-sintering, hot isostatic pressing and heat treatment are performed to increase mechanical properties. The parts are made using S7 tool steel powder process to a 7.5 grams per cubic centimeter density and a tensile strength of 1,850 megapascal. A 2-stage grinding process is required to achieve the 0.1 millimeter tip position specification. The grinding process includes machining the 2 main datum diameters on the body and the functioning tip of the striker. The position of the tip to the primary body of the component is critical for part functionality. The parts are finished with an electroless nickel coating. In the hand tools recreation category for metal AM components, a grand prize has been awarded to Parmatech Corporation for a putter head and hosel made for Cobra Puma Golf and used in the King Supersport 35 golf putter. The use of AM technology allowed designers to place or remove material strategically to optimize mass distribution, stiffness, and flexibility to achieve optimum performance. The flexibility of AM processing allowed collaboration between producer and customer to develop a unique lattice structure that eliminated the need for supports during the sintering process. The use of AM processing also allowed the rapid design, review, and testing of 57 design iterations, permitting the customer to test the characteristics of sound and feel important to golfers when striking a ball, but not easily simulated in design software. The flexibility also allowed production of both right and left-hand versions of the putter head and hosel without the need for tooling changes. The parts are made using 316L stainless steel. The strict cosmetic polishing, PVD coating, and milling requirements could only be met by achieving a relative density of greater than 99%. In the hand tools recreation category from MIM Components, a grand prize has been awarded to ARC Group worldwide for a quick disconnect sling mount assembly used for a variety of small handheld devices like binoculars, cameras, and firearms. Detailed design discussions with the customer allowed for a near-net shape molded assembly. Utilizing MIM enabled the incorporation of smooth transitions and rounded edges, as well as the elimination of any machining marks on the visible portions of the parts. 2 of the parts are sintered to near-net shape and sized. The 3rd part requires no sizing step. All 3 are heat treated and given a ferritic nitrocarburized finish. The parts are made to a 7.5 grams per cubic centimeter minimum density using MIM 4140. In the hardware appliances category for conventional PM components, a grand prize has been awarded to Metalpo Ind Ecom Ltda and their customer Group Seb Arno Clock Krups Panex Panedo Rochedo for a soft magnetic composite superior and inferior stator for a monophase induction motor for a ceiling fan. The parts are made using an iron powder coated with an insulating inorganic material that has high resistivity, and the parts have excellent magnetic permeability. A high compacting pressure of 800 megapascal is needed to achieve the 7.4 grams per cubic centimeter minimum density. During engineering, the proper tooling material was identified, resulting in reduced tool wear and increased tool life. The parts are cured rather than sintered, and a special fixture was required to check the strength of the cured component. The component was specifically designed for the PM process to take advantage of the 3D magnetic flux. The use of an axial flux motor resulted in a change from 152 mm to 80 mm in the outer diameter, less copper wiring, a 76% reduction in the mass of the motor, and 35% less energy consumption with less noise in service. In the medical dental category for MIM components, a grand prize has been awarded to OptiMiM for a compression frame used in Nextremity Solutions' Lapidus system for holding and aligning the targeting drill guide during tarso-metatarsal fusion. The parts are produced using MIM 420 stainless steel in a single cavity open and shut mold with 2 slides. The first forms the rectangular opening, and the second the 2 holes at 60-degree angle on the opposite end of the frame. Hot isostatic pressing is required to achieve an average density of 7.7 grams per cubic centimeter. After hot isostatic pressing, an annealing process is performed prior to secondary operations. The parts can be sized in a die with 2 slides so that forces can be applied in perpendicular directions to the parts. A hole is drilled and a countersink added. The frames are vacuum heat treated and tempered to meet a 40 HRC minimum hardness, and the frames are passivated prior to shipment. Ladies and gentlemen, these are the winners of grand prizes in the 2021 PM Design Excellence Awards competition. Please join us in saluting their achievements as we invite company representatives to come to the stage to accept their awards.